Welcome to Graphs of Quadratic Equations. So we're going to talk about when you have an equation that has an x squared in it, what does the graph look like and how do you do it. First thing, we've already learned standard form of a quadratic equation is ax squared plus bx plus c. So the way we determined a, b, and c before for our quadratic formula is still going to apply. The graph of a quadratic equation is called a parabola. Not parabola, it's parabola. Important parts are the vertex, so the lowest point and the highest point are called your vertex. To determine if it opens up, your a, or that x squared term, is going to be positive, and if it opens down, your a, or that x squared term, will be negative. So if it's positive, it opens up. If the x squared term is negative, it opens down. So this is all the information you're going to have to find when you graph a parabola, so it's going to be very important to write this down. Now, I do kind of have it out of order because the first thing that you find is your axis of symmetry. If we go back and look at the parabola, you will see that the parabola has line symmetry. So your line of symmetry, or your axis of symmetry, is that line of symmetry that goes down the center of that parabola so you can see the mirror image. Again, on the other parabola, the axis of symmetry is that line that goes straight down the middle. Now, the formula to find your axis of symmetry, x equals negative b over 2a. So it's going to be the equation of the line x equals and then a number. You're just going to have to work this out. Once you do that, you're going to have to take that and plug it into your equation because that's the x value of your vertex when you find your vertex. Plug that in for x in the equation, that will find the y value of your vertex. And then another easy point is always your y-intercept, which is going to be c, that number that does not have a variable with it. So let's go ahead and start with our first problem here. We want to find the axis of symmetry and the vertex of the equation y equals 3x squared plus 12x minus 8. So first thing we're going to do is our AOS, which is our axis of symmetry. We are always going to do your negative b over 2a. If you remember, it goes a, b, and c, because it goes x squared, x, and then no x. If it's negative b, this is a positive 12, so we're going to start with negative 12 all over 2 times your a, which in this case is 3. So it ends up being negative 12 over 6, which is negative 2. So my axis of symmetry is x equals negative 2. To find the vertex, that negative 2 is the x value of my vertex. The best way to always find the y value is you take this x and you plug it into the original equation up here. Put it in for both of the x terms, and that will give you the y value. So we're going to write down y equals 3 times negative 2 squared plus 12 times negative 2 minus 8. Please don't forget you have to do the exponent first before you can multiply anything by 3. So negative 2 squared, remember no matter what your calculator says, that is going to be a positive 4. Plus 12 times negative 2 minus 8. So y equals 3 times 4 is 12. 12 times negative 2 is negative 24, and then minus 8. 12 plus negative 24 is negative 12, and then minus 8 would be negative 20. Just double checking that I did all my math correctly. 4. So negative 24, negative 12, negative 8. Okay, so my vertex is at negative 2, negative 20, and then my axis of symmetry is at x equals negative 2. Now, these are always the first couple things you're going to do to graph a parabola. So we're going to take a look and try to do that again here in this, for this equation. We're going to graph it over here. The method that we use to graph to start with is an XY table, so you will need that, but we're not going to fill it out like we did a line where we did negative 2, negative 1, 0, 1, and 2. We're not always going to use those numbers. We're going to use different numbers each time. So what you need to do is you're always going to start off by finding your vertex. So there's your A, your B, and your C. Start with your axis of symmetry, which is going to be your x equals negative b over 2a. Since your b is already a negative 8, you're going to make it positive 8 over 2 times 2, because your a was 2. So that would be 8 divided by 4, which equals a positive 2. So your axis of symmetry is at x equals 2, which means your vertex is going to be at 2 comma something. Remember to find the other value of your vertex. You need to take that 2 and plug it in for both of the x's up there. So y equals 2 times 2 squared minus 8 times 2 plus 7. Square the 2, so be 2 times 4 minus 16 plus 7. 2 times 4 is 8. So y equals 8 minus 16 is negative 8 plus 7 would be negative 1. So your vertex happens at 2, negative 1. Now, why do we have to find that first? Your vertex is that middle point in your parabola. So what we're going to do is we're going to take that and put it in the middle of our xy table. So our vertex was at 2, negative 1. And then since a parabola is symmetric, we're going to put the two numbers above and below 2. So the next two below 2 would be 1 and 0, and then above would be 3 and 4. Because it's symmetric, one nice thing that we can do is when I plug 1 in, whatever that answer is, it's going to be the same answer as when I plug 3 in. So if I plug 1 into the original equation, because that's going to be the only way I can fill in that spot, y equals 2 times 1 squared minus 8 times 1 plus 7. So y equals 1 squared is 1 times 2 would be 2 minus 8 times 1 is 8 plus 7. So y equals 2 minus 8, which is negative 6, plus 7, which will give you a positive 1. So that would give you the coordinate of 1, 1. Since it's symmetric, like I said, if you plugged in 3, you would also get the same answer of a positive 1. So I know those two answers are the same. Then I'm going to plug in 0. So if I plug in 0 here, that means that cancels out and that one cancels out as well, because anything times 0 is 0. So my answer would just be 7. So because 7 is there, it's also down here. So what I'm going to do is I'm going to graph those 5 points. So over 0, up 7, over 1, up 1, over 2, down 1, over 3, up 1, over 4, up 7. This time, because we are actually graphing the equation, we are going to connect those dots. And I also want you to realize that we do have your axis of symmetry there at x equals 2. And there's the graph of your parabola. One way to check and make sure if you are correct, please remember your a is positive, so the parabola should open up. So that would be correct. I have one last problem to show you. Tell whether the function has a minimum or maximum, then find the value of the minimum or maximum. When we're looking at a parabola, remember it could either open up or it could open down. A minimum would be the lowest value you could have, so if we're looking at a parabola, that's going to happen at your vertex. So basically, if your parabola opens up, it's going to have a minimum value. If it opens down, it's going to have a maximum value. So if your a is positive, you have a minimum. And if your a is negative, you're going to have a maximum. Again, because it's your highest and your lowest point. So if we're looking at this, notice my a value here is positive. So that means it would open up, so it would actually have a minimum value. And it says, besides that, find the value at the minimum. So what I want you to do is go ahead and find the vertex of this parabola, and that's the minimum that it happens at.